in the artificial intelligence. So if I talk about the various kind of the approaches what we have covered in the our previous example. So you have already seen the many algorithm which is related to the AI. And in artificial intelligence, we have also seen the search strategy. Such strategy means what is the start goal we have and what is the goal state we have. So from start to goal state, what are the various mechanisms or searching technique we can apply to goal to receive the goal or to achieve the goal with the minimum cost, with the help of the minimum cost and followed by the high efficiency. So all these points we have seen the various algorithms. And what are those algorithms? If you remember the BFS, that is, we have the two types of the our searching mechanism. One is uninformed, other one is informed. So uninformed is known as the blind search. If we talk about the uninformed, so we have seen the BFS, we have seen the DFS, and we have also seen the uniform cause search. But talk about the informed search, that we have the two very important algorithm under this category. One is greedy search and other one is a star search. And after seeing the A star algorithm, we have seen the extended version of the A star, that is known as the AO star, that is the and or graph, by which we have seen. That is example of the problem graph. And after this one, we have also seen the very important topic in the previous class, that is the heuristic function. So why heuristic function is required and how heuristic functions play important role to sort out the problem to get the good efficiency of the such algorithms. And all these things we have seen. So now it's time to see the hill climbing algorithm. So as the name suggests, an algorithm that is used to follow the basic rule of basic concept of the hill climbing and why it is required. So first, I would like to draw a simple drawing. In from that drawing, you can easily understand. Let me explain the thing properly. So first, let me right now. Are you able to see the blank screen? Just accept to the logo. Are you able to see the blank screen?
Yes, sir.
Yes, sir.
Yes,
Oh,
sir.
good, good. So what I'm doing, there's a person. Just please listen. This is a very simple problem. So there is a problem we have, and I'm just trying a simple person example. This is a person. Okay, this person is right now sitting in a city. He need to move to the B city. You can see just at the bottom side, I'm just trying. The person can go by directly via the A to B city with this path, or there's another path, because in this world we are not following a single path, we can have the many paths. So this person can go via this path. This is another path, so I'm drawing by the different color. This person can also go by the another path, so I'm also taking the another path, that is the this path you can take. This path contains the, suppose this path just covering the distance 150 kilometer. This may having the 100 kilometers, no issue, or this may can have the 110 kilometer. So from this point, you have very simple concept in your mind, sir. I must go by the 100 kilometer path because I can save my time and fuel. So you can save the energy, you can save the time, you can save your cost. So you will choose the this 100 kilometer path. Okay, I can give the name over here. That is a path one. This I can give the path B. Also path two and path three. Is it clear right now? So according to you, which path you will like to choose? That is the part two. Am I right or not? Tell me yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay, so I'm just simple drawing a very
Yes,
simple
sir.
concept. Yeah, yeah. So I got it. All these paths are the supported by the very good road connectivity. Okay, so okay, do not believe in the my good drawing, but I'm just trying to explain my idea, whatever I have in my mind. All these things are not mentioned in the books, but I'm taking very simple concept. This part too you can cover, okay, by the 50 kilometer and this path you can also covered by the suppose 35 kilometer. So what is this example is saying? There is a hill. Okay, there is a hill. So what you will do to save your time and to save your cost, what you will do, you will cover a to this hill, you will cover by the road, so 50 kilometer you can cover. Then as a person you will try to climb this hill, that is the point. Then you will try to climb the hill, and then after this point, so this cost, suppose this cost is only just this covering this hill, it took around a 2 kilometer distance. And then after completion of this hill climbing, and after getting down from this point to this point you are covering, that is 35 kilometers. So total cost you are getting the 50 plus 2 plus 35. So how much total cost I am getting on terms of the kilometer? 52 plus 35, it means you are getting the 7 and 87, 87 kilometer. So out of the 150, 100 and 110, so among all these kind of the kilometers, you are getting the 87 kilometer is better path I can choose. Just tell me right now. So which path you will choose right now? That is a new path that is supported by the climbing the hill. Just tell me right now. Is it true?
Yes, sir.
So
Yes,
this
sir.
is the yeah, this is the reason. This is the reason which is known as the hill climbing algorithm. So from this point, you are getting there is a hill. You will climb this hill to get the best solution with the minimum cost. Am I right or no? Tell me yes or no. So why I'm choosing the hill? The path 4. This can be known as the path 4. So path 4 will be better to complete complete distance to achieve your goal. You can say to achieve your goal, to achieve your goal with minimum cost, with minimum cost in terms of best path, best path in terms of minimum cost. This is known as the best path. And that is the reason from this concept we will see the hill climbing algorithm. Now the idea is clear to what we have to see in this our topic. Now it is clear right now? Yes, yes, tell me right now. It is clear
Yes,
to
sir.
all? Yeah. So this is the scenario we have seen in our mind what we have to cover in the hill climbing algorithm. So from this point, we have a very simple concept in the hill climbing algorithm in the AI. So the first question we should have in our mind. So what is the hill climbing algorithm? So hill climbing is basically heuristic search algorithm that is used for the mathematical optimization problem in the field of the artificial intelligence. So, given a large set of the inputs and a good heuristic function, the algorithm tries to find the best possible solution to the problem in the most reasonable time period. So, you are focusing on the my word, just what I'm speaking. The purpose of this algorithm to try to find the best optimal, or we can say the possible solution in terms of the most reasonable time period. It means you're trying to look at the minimum time, you're just trying to cover the distance, as I've already written. This solution may not be absolute, or we can say best, that is a global optimum maximum in terms of the mathematical I can speak. You have any idea about the local maxima or minimum maxima, local maxima, global maxima, and a local minima and a global minima. So we can look, we can say there is no guarantee the optimal best solution we can have, but we can say with the minimum time we can save the our time as well as the distance. So There's no guarantee every time I can cover this distance by the 87. You can see this image right now. Suppose maybe the distance can be maximum, distance can be maximum, but after covering or by reaching the hill or while choosing this path, maybe I can save the time. So ultimate objective over here in the hill climbing algorithm, with the minimum time I need to try to solve my problem. So the definition above implies that hill climbing solves the problems where we need to maximize or minimize a given real function by selecting values from the our given input. And the great example of this I can take a traveling salesman problem. So this is a person I already drawn over here. You can see on the screen a person who is just moving from the one city to another city by choosing different path, but he is choosing the path 4 and followed by the hill climbing approach. So we need to minimize the distance traveled by the salesman by using the time. So here we have done this problem. So this problem is known as a traveling salesman problem. Now the problem is clear, the concept is clear. After this point, we have some certain points, and those points are required to understand properly. So, what are the important points we have to cover? And this point is telling to us what are the various features of the helical. So, step by step, I will tell you. So, before moving to this point, let me write now. First, the basic idea is clear. The concept is clear. What is the hill climbing algorithm? Or should I
Yes,
explain?
Yes, sir.
Okay. This theory I'm speaking right now because this theory is not need to speak much more, so I'm skipping such theory. I'm just giving the theory for notes purpose, but whatever I have in my mind, so I will speak over here. After understanding the this hill climbing algorithm, so let me explain the features of hill climbing algorithm. Hill climbing algorithm. Yeah, this one. Hill climbing algorithm. So from our diagram, you can note down. Can we say first point? Can we say first point? It carries out a heuristic search. Tell me yes or no. If I'm writing this feature, it carries out a heuristic search. This could be a feature. Tell me
yes,
yes or
sir.
no. Okay.
Yes, sir.
Okay. Super.
Yes, sir.
So let me explain this feature. Okay. So this feature is very important feature to understand the hill climbing. So this feature is saying to us a heuristic function is one that ranks all the potential and alternative in a search algorithm based on the information available. So in the heuristic search, we have seen the two type of the our searching. One is the uninformed search and informed search. So in the informed search, we have seen the greedy search, style. So this is the informed search we can use to sort out our problem inside the hill climbing approach. And it is a heuristic search. We can say it carries out of the heuristic search. So it helps the algorithm to select the best route to get its solution. This basically means that the search algorithm may not find the optimum solution if we talk about the BFS or the FSA process. Uninformed because something is not given by the in terms of the heuristic pattern. So uninformed search algorithm does not contain any kind of the heuristics value, as we have seen the various example in our previous classes. So we will use the informed search to sort out our problem by putting the one important parameter, that is a heuristic value, and that function by known as the heuristic function. So, the basically such algorithm does not or may not find the best or optimum solution. So, to this problem, we have the heuristic search we have to use. So that is the reason we can say hill climbing algorithm follow or carries out the heuristic search, and it will give the best possible solution in a reasonable amount of time. So to save the time, we can say. So this is the one point we can say. Next features I can speak over here. It is a variant of the general and test algorithm. So as the name suggests, I can write over here. I can write over here. It is a variant of generate, generate and test, generate and test algorithm. So as the name suggests, generate and test. Can anyone tell me right now what is mean by the generate and test? Just tell me right now.
Sir, we didn't try.
Okay, we can try and test. Okay, so we have to generate and then test. I can draw its diagram, then we can easily understand what is the flow chart of the generate and test. Let me use a different color to give my idea. Suppose I'm selecting the current solution. I'm selecting the uh, present solution or the current solution. And then what I will do, I will evaluate my solution. Evaluate the solution. Then I have a very big question by applying some parameter. Is my solution? The solution is solution is solution the best? This is a big question I have to keep in mind. So yeah, is solution the best? So if talk about the flowchart, so I can put into this one into a box. This is I can put into this one in a box, and this would be undoubtedly a diamond box. So I'm just not drawing the diamond, but I'm keeping into a just understanding purpose like this one. This would be diamond box because this is a question as per our term. So generate and test means we are generating the solution. What it means? We are generating the solution, generating the solution, generating the solution, and test whether it is the solution as we have planned or we are thinking the solution. So this is the meaning of the generate and test algorithm. So if the solution is not best as our desired problem, desired solution, we can say if it is okay, so we will stop our this. If it is yes, then we can. If it is not yes, then we will again select the current solution because we can have the multiple solution. If you know the problem and you can design the many solutions, so we will use the we will choose the optimum solution. We will choose the best solution, but we will check the desired solution whatever we have chosen it is the best or not. So we have to generate the solution. We have to test whether the solution is best or not. So this is the reason we can say this is known as the Helicalamin algorithm is a variant of the generate and test algorithm. So that is the point we have taken. So I've explained over things, everything here. So now it is clear to all right now, and just I can speak more detail about over here. The first step is saying to us generate the possible solutions. We can have the multiple solution and evaluate to see it is expected solution or not. Second step you can say. And third step is telling to us if the solution has been found, then we can quit as we can go to the step number one, that is select the current solution, present solution. This is the generate and test algorithm, the basic simple. Hill climbing takes the feedback from the test procedure and the generator uses it in deciding the next move to the search space. So hence we call it is a variant of the generate and test algorithm. A real example I can take. First, you are trying to sort out any problem. Okay, so what you will do? Oh, sorry, it is the problem which is taking the much time. So what I will do? I will try to find the another solution to get the minimum time. So what you are doing? Previously, you have generated solution and you test. It is a not, sir. It is not a good solution. Let us try to another solution. So what you are doing? You are trying to generate another solution and trying to find the best solution. And this approach is known as the generate and test algorithm. So now this step is clear right now. So this is the second feature of the Helicalamin algorithm. This is clear to all right now. Just tell me right
Yes,
now.
sir.
It's okay. Third point I'm remembering in my mind, so I can speak over here. Third point, it is a greedy approach. It is a greedy approach. Yes, can anyone tell me right now what is mean by the greedy approach? What is mean by the greedy approach? Just think and tell. Just you have to speak something over here. If you remember the greedy search algorithm, if you remember the greedy algorithm in the data structure or in the algorithm, so think and tell me what we have done the greedy search algorithm. So all these points are already available in our mind. Just tell me right now. All these things we have already seen. So I'm asking to you. In the greedy approach, what we have to do?
Sir, we will choose the most optimum solution.
Okay, that is a good point. So can you explain your idea in more detail?
Sir, we generate means all the optimal solution and we choose the best one of it.
Okay, that is a good one. So in the greedy approach, what we have done? Suppose we are selecting the first solution. Let me take an example. First solution, and I'm selecting another solution. I'm selecting the second solution. I have trying to solve the my problem. So I'm getting the multiple solutions. So I'm selecting the first solution, selecting the second solution. After selecting these two solutions, what I will do, I will try to compare. So this is the solution one. I can write over. This is solution two. So what I'm doing, I'm just trying to compare both solution, S1, S1 and N, S2. So I'm trying to compare these two solutions. So after comparing this solution, if I can say if S1 is the S1 is the best solution, okay, so I will choose this one as S2 will be the my best solution. So I can choose only the best one solution. So compare the both solution. Suppose if S1 is best solution, then I will choose this one and then I will exit. If S1 is not better, S1 is not better. So by default in the else condition, else S2 will be the better or S2 will be the best. So after choosing this one, we can also exit. Okay, let me put into the simple way. So this is the greedy approach. In the greedy approach is saying to us, we can have the multiple solution, but you have to choose the optimum solution after comparison. And so, what is the parameter we can compare in the greedy search? What we have used? We have used the cost. So after putting the all the distance, all the cost in the our path, so we have to compare the solution. So we are getting the this path we can move or this path we can move. So which path you are moving? The path which are having the initial level, the minimum cost. So I'm choosing the that path. So this approach we have seen in the greedy search approach. Again, I have to use the diamond symbol over here, but for understanding purpose, I'm just using only the this box only for understanding purpose. So if S1 is best, then I have to choose the S1 as S2 will be the best. So this is the point. So after choosing the best solution, one S2 or S1, then I will terminate the my approach. So this is the reason we have a greedy approach. So what are the features of the hill climbing algorithm? It carries out the heuristic search as the name suggests. So we can say. Second point, it is a variant of the generated test algorithm. So what is generated test algorithm? I have explained over here by the help of the flowchart. Next one, it is a greedy approach. So select the first solution S1, select the second solution S2. Then I will compare which solution is better. Suppose S1 is best, so I will choose S1. If S1 is not best, then I will choose S2. So then I will exit from the my approach or solution because I got the my final solution, that is a S2 or S2. Now, these are the three important features of the algorithm. So I mentioned over here. Now it is clear to all right now. These are the three important features. So before understanding the more details about the hill climbing approach, we have to keep in mind what are the various features which is supported by the hill climbing approach. Now it is clear to all right now. Yeah. So far, basic of the hill climbing and hill climbing features are clear. Yeah, please tell me. You have any problems? So please let me know right now. Okay. So in terms of the artificial intelligence, what we can say, a hill climbing approach we are following. So a hill can have the various points in terms of the mathematical. Because I told you the hill climbing algorithm is a mathematical heuristic solutions supported by that. So these are all theories I'm skipping right now. I would like to tell more about the state space diagram of the hill climbing algorithm. So what is the state space diagram? You can see observe over here the state space diagram for hill climbing we have. So state space diagram is nothing which is the graphical representation of the set of the state that is the input of the search algorithm can reach can reach and the value of the our objective function, the function that we can intend to get the minimize or maximize. So here we have 2 points. One is the x-axis that denote the state space. State space. So state space means state or configuration our algorithm may reach. You can see on the our graph. So on the x-axis, what are the points we have? Just let me use a different color so for getting an idea. This is our x-axis, state space. So this is our x-axis. So what we are seeing today on this slide, we are seeing the this is known as the state space diagram of hill climbing algorithm. So in the exam time, if I'm asking these questions, draw the state space diagram of the hill climbing. So you have to draw this diagram. I have to explain all the points. What are those points? So the global maximum and local maximum, flat or local maximum. Everything you have to write. So this is the point. Please keep in mind all the points. So and on the x-axis, what we have the state that is the configuration of the our algorithm that we reach, and y-axis denote the values of the objective function. And what is the objective function? Objective function means the function that we have to intend to get the maximize or minimize. And the y-axis is not the value of the objective function corresponding to the particular state. So best solution will be that the state space where objective function has maximum value or global maximum. So this maximum value we can say known as the global maximum. Okay. So I hope you have already gone through this kind of the terms. So can anyone tell me right now what are mean by all these things? Just anyone who is remembering any point, so please you can share a point right now. Have you heard all these terms? Global maxima, global minimum.
Yes, sir.
Okay. So we have some different reason in the state space diagram. So first I'm choosing the local maximum. So what do you mean by the local maximum? Just tell me, right? What is the mean by the local maximum? Local
Sir,
maximum.
the value is
Sir, the
largest
minimum
between a
in the
given range.
Please speak one by one. So just
Sir, it is
who?
a maxima between a given range.
Hmm. Okay.
Means not the range of the whole range of the function, but between a specific range.
Hmm. Because on the hill there are the many point could be. So there's no guarantee in this world. Each and every hill we are having in this world are having the same form. So there are many kind of the hill we can have. So there could be the many points which is supported by the hill. So from the that general terms we can represent the all the terms over here. So those are the global maximum, local maximum, flat we can say, solder, state space, current space, everything we have. So first I'm asking you what is mean by the local maximum. Okay, so what is one telling the answer and what about the other? Just please can you complete your answer?
Sir, and flat local maxima could be that means the neighbors have also the same value.
Hmm, okay. Yes. Any other students, please? This flat local maxima can be say this is a plateau. This flat local maximum, you can say this could be the plateau. Just look at this point. This would be a this would be the plateau. This because name is given the flat local maximum. Okay. So I was talking about the first local maximum. So local maximum means it is a state which is better than its neighboring state. However, there exists a state which is better than it, that is a global maximum. This state is better because here the value of the objective function is higher than its neighbors. Am I right or not? Tell me yes or no. You can say. Anyone who is not agree with me. So first tell me right now. It is a state which is better than its neighbor states. However, there exists a state which is better than its, that is a global maximum. So this state is better because here the value of the objective function is higher than its neighbor. That is the point. And the student also telling the same answer, so I'm speaking the same answer. This is a local maximum. So tell me yes or no. This concept, this term is clear right now.
yes, sir.
This is the higher value,
Yes,
which is just a higher value, which is represented by the its neighbor. Okay. So what about the global maxima? So can you tell me right now what is mean by the global maxima in this state space diagram? It is clearly mentioned, but I need the answer from your side. This global maxima, just like you can say, this is the peak. Okay. So if it is a peak point, so what are you thinking about the peak point in your mind? So you can relate to the peak term with the global maxima. So you can speak about the global maxima in simple way. Just tell me. Just tell me because everything is in front of you. So I need the answer from your side. What you're thinking, what you have in your mind. So global maximum. I can
Sir,
speak, but I
it is maximum point of given of means out of all points.
okay. Good, good. Any other student, please tell me the answer. Just you can speak in general way, no issue.
sir. I think it is the best possible state in the state space diagram of the
Okay,
Helicalamin algorithm.
okay, okay. So see. if I draw a very simple point, just like let me draw a simple example over here. Say, so there is hill like this one. There is hill like this one. So this is the peak point. This is the peak point because this is the peak point of a hill. Can we say yes? Tell me yes or no.
Yes, sir.
Okay, so these peak points, what is containing by this point? Peak point. This contain the highest value. So if talk about the objective function, so this value, just this is global maximum contain the highest value of the objective function. Respectively objective function you can say. So what is mean by the global maximum? It is the best possible state in the steady space diagram. This is because at this state objective function has the highest value. Can I say right this one?
Yes, sir.
Yes, sir.
Yeah. So this is the highest uh, value of our objective functions. Yes, this is the point. So everything is in front of you, but you need to understand and you have to write in appropriate form. Okay, if talk about the flat or local maxima, so we have already discussed. So this is the plateau. So it is a flat region of the state space where neighboring states have the same value. So this is the point. So this is a flat. Okay, so this is a plateau which is known. So in this some reason, I can't take right now, but I can just take this example because it's interesting. Like, so there will be some area or region where the we can find the flat. So this flat is also known as the plateau. So it could be on left side, right side doesn't mean, but I'm taking right on the left side. So this could be our known as a plateau. So, and unlike the plateau, there could be the risk. Yes, of course, we can also have the risk. Okay, this shoulder also known as the our plateau part. Risk. So risk is what? Risk is a reason which is higher than its neighbor, but it has a slope, and this is a special kind of the local maximum. So if it is this is a risk we have. So if talking about the risk, so just look at this point. So here we have some slope like this one. So here in this point we can also have the risk. So this is what, this is just like a local maxima or a special kind of the local maximum point where the higher it has the value higher than the its neighbor, but it has slope. It does not have a local max. It does not have a flat. If it is having flat, it is known as a local maximum. So at the bottom side, you can see there is a very important point. We have a current state. So what is the current state telling to us? The current state means the region of the state space diagram on CK which are currently present during the search. So maybe we are on this position. This is the position. This position defining at we are on this state or this position to search the our information. So current state means I can write over here the position or the location, we can say the position or the location to search to search. So this is known as the means the present state. Okay, so we can say I can write correctly. The means this is the present, means present or current location. Just look at my example on the hill. You can see if I'm just trying to just being a person, I'm just trying to uh, from this point. So what I will do, I will cover this distance and then I will cover this distance. So suppose I'm this position. So this position, if I'm on this position, so this is what, this is known as my current position or current location. This is known as my current location. So this is also known as the current state in the side. So everything is I'm drawing with the general example. So to know what we can say. So these are the different reason or different terms that we can see in the state space diagram. So in the exam time, I can ask very simple question, just explain the Helicalamin algorithm and what are its features, and just draw or sketch its state space diagram to explain the concept of the Helicalamin. So you have to explain all these terms. Okay, now it is clear to all right now. These are what are the points we have. Is it clear to all right now?
Yes, sir.
Okay, so what we have covered so far, just let me explain. So far we have seen the what is mean by the hill climbing algorithm and why hill climbing algorithm is better than the other one. So because we can find the best possible path with the minimum distance along followed by the time period, we can say minimum, or we can also have the maximum minimum. But we are looking as our general problems, we will see the minimum time period and minimum time. We will got the minimum cost. So this already explained, and these are the features. So it is a heuristic search. Of course, we are looking the heuristic search. So the function heuristic function will be involved here into the our hill climbing algorithm, and it is variant of the general test algorithm. What is mean by the general test algorithm? I have explained over here. And why it is the greedy search? Because in the greedy search approach is saying to us, we can have the multiple option and we will try to compare all the possible solution, which solution could be the better or best. So we will choose the best one solution. That is the approach which enter come into the greedy. So we will use this approach, and this approach we also use in our example. This morning example we have seen. Why I'm choosing the path 4? Why I'm not choosing the path 1, path 2, path 3? Because from the path 4, I can get the minimum distance, I can save the my time as well. So here implicitly, what I'm following the greedy search approach. Okay. Now come to the point. It is a very all the things we have seen. So statistical diagram we have seen. This is the our diagram, and it's a theory you can find from this point right now. So these are the various points we have seen. Now, so we have covered the three topics right now in today's class so far. So any doubt you have, so you can ask, or we can do the other thing. Just tell me right now. Else we can have the
No doubt, sir.
yeah. So it is better approach I'm taking right now to explain my idea by the drawing way or just writing simple way. It is better idea. Is it good? You're getting something here with the my way. I'm just drawing the sketch. I'm drawing the everything.
Yes, sir.
Okay, so type of the hill climbing I'm taking right now. So what is the type of the hill climbing? Because in this world I have already spoken few couple of the minutes ago. In this world there is a no one kind of the hill we have. We can have the many type of the hills. So if we're talking about the what kind of things we have. So here we will see the type of the hill climbing. So first one I would like to take the simple hill climbing. As I told you, this is the today's topic will be theoretically, but I'm trying to explain my idea with the help of some drawings pattern, so you can easily understand. So this type of the hill climbing we have to keep in mind. So just think about any hill. So first, let me take the image. It is available. Yeah, I would like to share one image from that mind. We can understand what are the various type of the hill we have. This is the. Then I will come to the next one. Now I think you are able to see the hill climbing, various hill climbing approach. What are the hills we have? So here we have some points: local maximum, plateau, and ridge. Am I right? Is it visible to all?
Yes, sir.
Okay, just keep in mind there are various types of the hills. So from this point, you can understand the types of the hills. Now, I'm coming to my point. So, what are the types of the hills climbing algorithms we can have? So, first one we have a simple hill climbing. So, just think there are simple hill climbing algorithm. So, what is the sense of the simple hill climbing approach? Simple hill climbing algorithm is the simplest way to implement a hill climbing algorithm. It only evaluates the neighbor node state. Please keep in mind. It only evaluates the neighbor node state at the time and select the first one which optimize the current course and set it to the current state. From this point, I'm remembering a very simple story. I've read many articles. So suppose you're trying to uh, climb the Mount Everest. So there are many paths. So which path you will choose? So you need some guide. You will follow the guide rules, instructions. So this is the best path you can you can climb the Mount Everest, so you can reach on the peak point. So I suggest to this path you can go. So this is the reason. So you are not a single person who can do. So you are the person who just trying to reach on the peak point of the Mount Everest. So what you will do, you need some guide. So you are not a single person. You're doing the same thing at the same time. There are multiple person who are doing the same thing. So according to the some guidance, some rules, we will follow our actions. So we will choose the best path, but which path is best because they have the some experience. So hill climbing approach is just using a heuristic function. The heuristic function is just like our guide. So we are following the some our heuristic functions values to get the optimal solution. That is the reason this is the feature which is supported by this one. So we can have the multiple paths, but we will choose the best one path as a uh, uh, first one, and we will try to optimize this to the best one or not. So which optimize the current cost and is set to the current state. This is the point. So from the current state, you will try to move to the next state. Then you will check. There are many states we can have. There are many possible paths we can have, but we will choose the best one depend on the our heuristic search approaches. So this is the reason heuristic search is more applicable into the hill climbing algorithm. So it will only check the one successor node and it find the better than the current state and then move else with the same state. And this algorithm has the many approaches I'm talking about right now, the simple hill climbing. And what are those? It is less time consuming. There's no guarantee, but we can assume that is the, if I'm using the less simple hill climbing, so I can have the less time consuming due to following the optimized path and let's optimum solution we can say there's no guarantee that we can get the more and good optimal solution but we can say we are getting the less optimal solution because we are choosing the best one path but it depends on the successor values I'm choosing but there is no guarantee the successor value or success rate I'm choosing as a best it could consume the more time it could consume the more distance so as a simple hill climbing I'm just choosing the successor state as our best one but as there is no guarantee our solution will be the best one so these are the three features I'm following but there's no guarantee I can get the optimum solution due to the less optimum solution policy so this is could be the our one reason simple hill climbing we have but what are the other hill climbing approach? Maybe in the other hill climbing approach we can have the better solution. Yes, of course we can have. So other solutions I have the steepest ascent hill climbing. So in the steepest ascent hill climbing, what we can have the steepest ascent algorithm is a variation of the simple hill climbing algorithm. This algorithm examines all the neighboring nodes of the current state and select the one neighbor node which is the closest to the goal node. And this algorithm consumes the more time as the search for the multiple neighbor. First, I would like to share the some theory and then I will explain some example with the term. This is the point. First, let me explain the simple hill climbing by the my diagram, then you can easily understand. Uh, yeah, this is the point. Just I'm just like this simple drawing example, just explaining purpose only. Suppose you are choosing this point, this is the current state in the simple hill climbing, this current state. You want to move this peak point, so you are moving in this direction. Okay, so what you will do, you can choose the this path, you can choose this path, or you can choose the another path because on the hill we can see only the one side right now, but on the other side we can have the multiple paths. So what we are doing here, from the current state, from the current state, from the current state, what you're doing, you are just looking at the only its successor state. It means you have only the one choice. So this is the reason one choice we have a less optimum solution. So solution is not our guarantee. So that is the reason. So I'm just moving this point. So this is what this is known as the successor current state only. because I have the only one option. So this state S1, suppose current state. So this state S2, S3, I can move, but I'm choosing the S2 only. It's a successor. I'm not choosing this one. So this is the reason I'm following the simple hill climbing. But if I'm choosing the S3 or S4 to check whether it could be better or not, or best or not. So the reason is that I'm choosing only the its successor only. So this is the reason I'm choosing only the one successor only. This is the reason it does not provide the best solution. So that is the point. We have the solution is not a current. So current state to only the one successor state I'm choosing only. I'm not choosing the other states. That is the reason. But that can be followed by the steepest ascent hill climbing. So what I'm doing, uh, we have a current state. Suppose S1 is a current state. Current state S1 to S2, S1 to S3, S1 to S4. So before choosing the its a successor state, what I will do, all these states compare, compare these states and select best one. So suppose I'm finding if I'm choosing the S1 to S2 and S1 to S3 and S1 to S4, I'm comparing S1 to S4 is the best one. So I will choose this path. And this approach is known as the steepest ascent hill climbing. Okay. So it compare all the its neighbor. So these are the neighbor node S1, S2, S3, S4. So all these are under coming to the neighbor. We can write over here. This is known as the neighbor. And I will choose the S4. Why? Because even choosing the S4, so my goal will be closer. So I'm able to see, okay, I'm able to reach my goal if I'm choosing this path. Suppose I'm choosing the S3, so my goal will be little bit far. So why I'm choosing the S3? So this is the reason I have this option, steepest ascent hill climbing. That is it. Now, these 2 points are clear right now. These two differences between the simple hill climbing and steepest ascent hill climbing. It is clear to all right now. The differences between the both ones are clear.
Yes, sir. But sir, can you show us show me the previous slide, please?
This one.
Yes. Yes, sir.
So
Okay.
everything is written in the notes purpose I've written. Okay, I'm explaining the same thing. Everything is written in the notes purpose. You can utilize all these things as a notes purpose. So no need to worry about any kind of the books or notes. My notes are very comprised notes and concise notes. It contains all the data. So the difference between the simple hill climbing and the variant of the simple hill climbing, we have a steepest ascent hill climbing. It is clear to all right now.
Yes, sir.
Okay, so I already told you we have the types of the hill climbing. So we have seen the two types of hill climbing so far. One is a simple hill climbing and the other one is steepest ascent hill climbing. So differences we have already got now. So next one we have stochastic hill climbing. So look at this example and tell me what is mean by the stochastic hill climbing if you have understood the properly the simple hill climbing and steepest hill climbing approaches. Look at the image, look at the diagram, and tell me how this one is different from the previous both. Yes, tell me right now. Okay. Before
Sir,
that, just before that, let me just give you idea. Then you can easily understand. Uh, in the simple hill climbing, what we have covered. Just let me explain simple hill climbing. I can write over here. Just what we have covered. In the simple hill climbing, we have a current state. This is S1. and we have S2, and we have S3, and we had S4. We have seen. Then I will ask you a simple question. From this point, we will choose successor node. Okay. So drawback, we know there is no guarantee we can get the optimal solution. So its successor node is S2. Okay. And S2 neighbors are the S3 and S4. But exponent successor node is S2. So I'm choosing the S2. But the drawback is that no guarantee, not able to get, I'm writing simple, we're not able to get optimum solution. Optimal solution. And while understanding any topic in the AI or any course in the computer science, try to connect all the things with the real life scenario so you can easily understand. And if talk about the our variant of the simple Helicalamin, so what was the steepest and Helicalamin? In this case, what I'm choosing? S1 I have, S2, and I'm just taking all the same thing, and S4. And of course, so all these S1, S2, S4 are S3, S2, S3, S4 are the neighboring node. So I have the two options. So I will compare. So what I'm doing, I'm compare all neighbor node or neighboring nodes. I can speak here, neighboring nodes. Okay, from current state and select best one. So here S4 I'm choosing because of minimum cost. Suppose just take an example, minimum cost. Based on the minimum cost, I'm choosing the S4. Now, that is my question. Just look at the image right now and tell me, stochastic cell climbing is what and how you can interrelate the stochastic, how it is different from the previous one. Two previous one. Just tell me. Yes, the student who want to speak, just tell me right now.
So it is randomly selecting any neighboring node and then evaluating the node.
Yes, okay. So everything is written in front of you. So how we can see the stochastic hill climbing? So I can explain like this one. Third one we have. Third one we have stochastic. Where it is this one. Yeah. Stochastic hill climbing. So stochastic hill climbing. What we have? We have what we are doing. S1 is the current distance supposed, right? S2 we have, and S3 we have, and S4. From this neighboring node, what you will choose? You will choose any random node as a current as a successor node or whatever node you can speak. So as a I'm speaking here about the S node, that is a as a next node, as a next node to reach at goal state. Now this is the stochastic hill climbing. You can read out from the red color. Now it is clear right now. So these are the differences between the all three kind of the hill climbing approaches. Now it is clear to all right now. Differences between the all these three kind of the hill climbing approaches. Now it is clear. Yeah. Anyone who need to ask any question? Yes, tell me. Anyone who need to ask any question? Else I can move to the next point. Yes, it is clear or not? Tell me right now.
Yes, sir.
Okay.
Yes,
So
sir.
after understanding this point, after understanding the Helicalamin approach, and also understanding its features, and after understanding its variant and its type, we have to understand what are the problems in the different region we can have. So we have seen the its state space diagram. So from that point, what are the problems we can have? Just look at this one. So problems in the different region we can have. Does no guarantee every point we are discussing every point or every locations or the position where on the such position is the best one. Suppose you're trying to reach on, it's trying to climb a hill. So the point you have selected that is the best one. No, there is no guarantee. The point you are on the some point on certain point you have, there is no guarantee this is the best one. The certain reason the area can have the problem. Yes, so we need to find the problem, and that is very important point to understand this complete to understand such topic. So hill climbing cannot reach the best possible state if it enters into the following reason: local maximum. Suppose I'm reaching on the local maximum, there is no guarantee. So I'm just I can reach the good position or I can have the good or highest objective functions value. No. So local maximum. So I can speak from this point so you can easily understand at the local maximum, never state have the value which are worse than the current state. Yes, of course possible. So local maximum can have the local maximum can have the worst value. Yes, it is also possible. Just look at this diagram. I'm going back to the previous diagram. Just look at the local maximum. I'm speaking about local maximum. So I'm thinking about the if I'm on the local maximum position, I can reach the highest value. No, maybe the global maximum just containing or representing the highest value of the objective function. So from local maximum to global maximum, I need to reach. Then what I have to follow? I have to follow the RIS and other parts as well. So there is no guarantee. The problem I can have. There's no guarantee every time I will have the problem, but I can have the problem. So this is the problem. So to overcome such problem in our mathematically or in the artificial intelligence, what is we can do? We can apply the backtracking approach. There's some point you have reached on the point. So what you will do? Oh, I'm on the wrong position. So what you will do? Again, you go back. So this backtracking will take your much time. So this is the reason we have a problem in the reason. So backtracking is a solution. What is the reason? Again, you have to go back. This problem I can explain or I can draw like this one. A to B you have covered, and A to C you have covered, and A to D you have covered. Now you are happy. So you are covering the 5 kilometer over here, 10 kilometer over here, and 5 kilometer over here. A to D you are reached. So you again choosing the another path A to D via E. So by E, it containing only the 4 and containing only the 6. So what you will do before reaching this goal, you are finding A to B I'm moving and B to C I'm moving, so it costs around the 15. But I'm finding A to E is another solution I can have. So what you will do again, you will go back, and this is known as the backtracking. So on the local minima or local maxima, I can have this problem. So the solution is only the one best solution, that is the backtracking. Is only the one solution. So the point it can have the worst state, and that is the current state. So this backtracking also possible. So local maxima can have, I can write here, can have uh, worst state. And if I'm choosing this path, no issue, I can get. But the problem is that it will take much time. So my objective to minimize the objective function. Suppose that my objective is to minimize the or maximize the objective function in higher value or the minimum value. But if I'm on the stuck in a worst case, so I'm not, my plan to just keep the minimum value, but it will increase my cost. That is not a good solution. That is a problem. Now this problem is given right now. In the local maximum, I can stop. So that is the reason I have to go again back to my previous points to reach my goal. And this really happened many times while those people who are really following the adventure. So what reaching a certain point, they find okay, I'm on the wrong path, so I need to go back to cover the my distance. It is really happening with the real life scenario as well. So same thing I have already explained. Now this is clear right now. The problem is clear. What could be the various problems? So first one I'm talking about the local maximum. Now it is clear right now. Yes, sir. It is clear or not?
Yes, sir.
Okay. Next one is the plateau. It's very simple. Everything you just need to connect your this point plateau. So on the plateau, all neighbors have the same value. Just look at this point. I can write like here. Suppose this is a state one, and this is state two. So these two states are representing by the our plateau part of flat area, and it is not possible to get the optimum solution, the best solution, because this is supported by all the neighboring node as a our uh, best solution. Look at this example. I've taken the previous one example. Suppose I'm on the current state S2 and S3 and S4, and all these states are also having the same values. Okay, so same values. This will get me confusion which state or next state I must choose to reach at the my goal node. So this could be another problem while following the plateau of flat local minimum. And so it provides me, I can write over here, it provides me confusion that which state I must choose, which state I must choose. So this is the reason. So you have seen many times in the real scenario, you have a this path, but you will ask a friend while driving or while riding here, which path I must choose, because I'm choosing this path. I don't know. I am just coming on the first time in this path. So which path or which road I must take? So that's the reason. So if both are having the same distance, then you will be confused. That is the reason. So to overcome this problem, we have to make a big jump and randomly select the state, and this is only the solution. So you can take the S3, but after choosing the S3, suppose I'm choosing the S3, there's no guarantee I am following the best solution, but I'm just trying. So maybe I can choose the S2, so I can get the optimum solution. So this is only just known as the which is known as the generate and test. So due to reason, Helicalamin approach support the generate and test feature. So if I'm choosing the S2 or S3 or S4, whatever the state you are choosing, so that defines the generate and test or algorithm. So that is a variant of generate and test algorithm. The reason is clear because of this one. So I can write over here for information purpose. It makes a generate and test algorithm. From this reason, we have to use the generate and test algorithm. So I'm choosing the randomly and try to get it. So chance that we landed on the non-paired reason. Okay, so from this point you can choose the any state and then you can jump to the next state. So this could be the another reason. Third one is raise. So raise I told you, but raise at any point on the raise look like the peak because of the movement of the all the possible direction is downward. We are moving to upward, downward, so there is risk we have. We can have the multiple raise, but we will not say we are reach on the peak point or we are reach at the highest point that is known as the global maximum. So what you will do, you could choose two or more rules before testing. So it implies you to several direction at once. And while stuck in the range, what you will do, you will choose the uh, random state to jump directly. This is one approach you can have, or another approach you can have. What the first one approach, if you remember, that is a backtracking. So you can choose one thing. Is that you can choose. Uh, I can write over here for information. If you uh, stuck in a risk problem, this is the problem I can say. So you have uh, comma, then you have two options. two options. First one, you can apply backtracking. You can apply backtracking. Okay. Second one, you can choose the randomly select uh, next node by big jump. That is the point. By big jump. So these are the two possible solutions we can have. This reason you could use a two or more rules before testing. So here we have already seen the two solutions by which we can overcome the problem. So we can choose any one of the options. So this is the reason we were not able to identify the global maximum at one moment because we are stuck in a race. We are again finding, oh, we are okay after we have completed the race. Oh, next state we are getting, so that could be the peak. But at the time we will stuck in a situation. So you can use any one of the option, backtracking or uh, this randomly selected option you can choose. So this could be the another option. So these are the our problems. What are the problems? Local maximum, pledge we have, and the other one is risk. So these are the three problems I've explained over here. Yes, anyone who have any problem in these three problems, so I can explain once again. Else, I can just give you idea about what are the applications of the Helicalamin. And for your just sharing this my point. So local maximum is this is the point. Okay, here I'm just on the local minimum, so I just think about this point. I'm on the peak point, but there's not a point, but other peak point or other global maximum we have. See, here I'm thinking about the I'm on the maximum point I have reached, but this is a local maximum, and this is a global maximum. So this is one our problem. And apply to, yes, this is the problem. So from this point to this point, I'm just look at the my uh, red color point. So here what I have in the plateau, I can have the same value by uh, multiple by multiple states. Those are the next. And raise means I'm just stuck in a situation. I'm just coming on this point, then again I'm going down, then again coming, then I'm going. So this is the case. So before reaching the peak point, I'm thinking about the sign on the peak point, but no, I'm again stuck in a ridge case. So these are the three problems we have seen in the hill climbing. So I'm also sharing this information here for your information purpose, and all details information you can find out here. So these are the points, right? Yes. Think and tell me right now any problem you have. Yes, tell me. You have any problem? Yes. In the problem you have any problem, so you can ask me. Else, I can explain the what are the its application of the hill climbing techniques in the AI, of course. Yes, tell me.
No problem, sir.
Okay, so last slide I can share with you, that is the application the hill climbing. So you can see there are the lots of applications we can see, but I would like to speak about the two beautiful examples of the uh, hill climbing in terms of the application. So one is robotic. In the robotic, hill climbing is mostly used in the robotics that helps or which helps their system to work as a team and maintain the coordination. I'm speaking once again in the robotics. We can use the hill climbing approach to understand the system as a work as a team and to maintain the coordination. And in the marketing is the best one example that defines that the team management and the various marketing domain where hill climbing can be used to find the optimal solution. Yes, of course, I'm taking the simple way. In the marketing there are many people are connected, but I will get the idea from the best marketing manager which idea I must choose to marketing the my product. So what I will do, I can have the multiple solutions, but I will choose the best one to increase the sale of the my product. So marketing manager will give the various ideas. So there are many marketing manager of the my product. So I will choose the best one. So in the marketing I can use. This is the only way. And uh, why it is required? Why it is required? It's very required because of a sell person who is trying to sell his product. So he need to cover the minimum distance and selling the more product. So in the minimum time and in covering the minimum distance as well, if the salesman or sales girls is trying to sell his or her product with the minimum time and covering the minimum distance, so this would be the best example. So marketing and robotic are the best one example. These are the two best examples to explain the Helicalamin approaches. So this is the reason I have taken over here. And rest of the thing you can see there are the many places, many area where hill climbing can be used, just like the travelling salesman problem, 8 queens problem, and integrated circuit design problem we can see. So I'm just taking image here to share my idea what could be the possible things we can have. Okay, so these are the what I mean by these are the basic ideas so far we have seen about the hill climbing algorithm. So today we have seen the hill climbing algorithm, feature of the hill climbing, types of hill climbing, and why hill climbing is more important. So and where we can use. So we have seen its theory in detailed way, in concise way as well, to understand all the points. So I've taken my example to explain your explain idea about the hill climbing. So what I did, I have taken the real life example. I have taken the simple example. So to explain my idea about the hill climbing algorithm. So this is a hill climbing algorithm. So now you have any problem, so you can ask me. And in the top about the applications, so marketing and robotics are the two area where the hill climbing is more applicable. Yes, sir. If you have any problem, so you can ask me. Else we can wind up.